Hey, this is Steve, and what we're going to do today is work on some more Julia stuff. So I really like Julia, so I want to just solve a bunch of problems in Julia and teach myself Julia. And I want to kind of teach you as well. So go to the board. Let's... Oh, yes, there we go. Now, what are we going to do? So, the problem... I want to solve a polynomial. So, let's do this. Let's just pick some polynomial. F of x. How about this one? Got a negative 10. Equals, yeah. So we want to, okay, yeah, essentially we want to solve, we want to solve this this thing here, and we can do this analytically, so it's really not too hard. Alright, that should be 0. Take 10 on the other side, and it's going to be plus minus square root 10. Cool. So plus minus square root 10, and what we're going to do is confirm this with Julia. So I'm going to head over to so I did a similar problem before, so you know, I don't know what I'm talking about. So start a new notebook. But first I want to check the value of square root 10. So square root 10. Okay, it's weird. Usually it takes a bit of time before the first cell runs. Still wait. Okay, so it's about 3.16. Write that. Okay, now let's try code this out. So the great thing about, okay, let's title this you know, root finding. So I already exists. Okay, fine. Underscore 1. So in Julia there's a package called and the way you import packages, you use the keyword using. So I'm going to import, in Python you say import, Julia you say using roots. So I'm going to hit that, and that's the outside package. Now the great thing about Julia is that you can assign, you can make a variable a function, type function, which is quite cool. So what we're going to do is we're going to generate a function that generates polynomials, which I think would be cool. So start off with what do we start off with a function. Let's call this function. Sorry, a function. And this function, what it does, it's going to generate a polynomial which we will solve. So we just say gen pol whatever, and it's going to take in a, and a is going to be the coefficient. So I forget what this is called in Julia, this thing, but it says you can take in any number of parameters. So in Go, I've heard it called like a variadic number of parameters. I don't know if it's the right terminology in Julia, but yeah. Anyway, so we're gonna say, so those are all the coefficients of the polynomial. So what I mean, can I? Maybe no. I'd like to scroll down. I guess not. I know how to put things on one page, eh? Okay, so if you have a polynomial, say g of x, right? And you want to, so this is what it is. So you've got an, right, the coefficient of that guy, so that should be x, that's minus, and so on all the way up to a0. Yeah, let's go with a0. So it goes from 0 to n, and so that's what those a's are there. So I really didn't prepare this too much, so I guess it's just but you know what, we're gonna try to do our best, try learn something along the way, hopefully. So what I'm gonna do here is I'm gonna say the order of the polynomial is equal to like number of coefficients you put in, take 1, because it starts at 0, right? Then I'm gonna define I'm gonna define a function. I'm gonna call it poly, and I'm gonna say function x, gonna return the sum of so I'm gonna make this is in Python, it's called a list I think it's called the same thing, a list comprehension. So you take the coefficients, x, sorry, that should be multiplied, and then you get 4 I in 0, starting at 0 all the way up to n, and we're going to end that, and in the outside function we're going to return the poly, yep, and then we're going to end that. So hopefully that works, and oh good, easy. So just check that. So what are we doing? So we generate a polynomial with this function here, and it's gonna return a polynomial, right? That's why return poly, and this thing in here, it's defining our polynomial. So here are the coefficients, yeah, and then here are these guys. So it's a bit so you just have to be careful, I suppose, because yeah, this is gonna be, it's gonna start at 0, so the first thing, so that'll be x to the 0, and then that'll be a1, right? So just make sure you don't get those confused. So we'll see if that runs. So yeah, so it generates this function which generates a polynomial, and then I believe just to find the zeros of find zeros is just the function. So that'll solve this guy here. It'll solve this one here. Yeah. Go back. Find zeros. Alright. In Python you usually can go shift tab and see what the function. Yeah, find zeros. Search for, okay, yeah, so it takes a polynomial something, and then it takes yeah, the domain, right? That's not too bad. So let's say a polynomial is going to be, okay, we don't need that right now. First let's generate the polynomial. We gen pol, and we're going to say that what are the coefficients? It's going to be we have a second order polynomial, so our equation 1, 0, 10, right? So that's going to be, so the 1 comes from, sorry, so this 1 from coefficient of this guy here. 0, there's no x, and actually, sorry, that should be negative 10, not 10, right? There. That's great. Now we have our, and we'll just call that P. And we'll define some domain where we want to solve it over. Okay, let's see if it outputs what we want. The suspense, eh? Okay, yep, and that makes sense. And that was our original that was our analytical answer there, right? Root 10. So it looks like we were able to solve polynomials in I was gonna say Jupyter. We did do that in Jupyter, but in Julia. Okay, so thanks for watching. I hope you guys learned something.